We've already talked about what a system of equations is and the three different types of solutions systems of equations have. Single solution, infinite solutions, and no solutions. We've solved them by graphing and we've solved them by substitution. Today I'd like to talk about using elimination with addition or subtraction to solve systems of equations. So it's just a method and to solve a system, and by elimination just means to get rid of something. Okay, so we're going to be getting rid of something in this part. So here's the steps for solving by elimination. Step number one is to write the system so the like terms with the same or opposite coefficients are aligned. So we may have to rearrange the equation so that we have like terms above each other, because we're going to set it up like a regular addition or subtraction problem, one on top of the other. The second step is to add or subtract the equations, eliminating, there's that elimination, eliminating one variable. And then we'll solve the resulting equation. And when we do that, we'll either have the value of x or we'll have the value of y. The third step is to substitute the value from step 2 into one of the equations and solve for the other variable. And with all system of equations, if with a single solution, your answer is an ordered pair. So I'll give you a minute to copy that down, and then you can start the video back up and we'll work a couple of examples. All right, let's take a look. Here's our first example. And if we look at this, we've got 4x plus 6y is equal to 32. Our second equation in the system is 3x minus 6y is equal to 3. If I look at this, we've already got our like terms lined up. In this case, we have opposite coefficients. So what I'm going to do here is I'm going to go ahead and set this up, and I'm going to divide it up so it's easier to see here. I've actually got three little problems I'm going to work. I want to eliminate this y. So if I have a positive 6 and a negative 6, the operation that would eliminate that and make it 0y would be if I added those two together. So I've got to add each one of these columns. So here we've got 4x plus 3x would be, that would give us 7x. A positive 6x plus a negative 6x, or excuse me, y, would be 0y. And then over here, when we're adding, 32 plus 3 is 35. So the resulting equation is basically 7x is equal to 35 because we eliminated the y, because 0 times y is 0. So now it's just a matter of solving for x. So we solve for x, divide both sides by 7. We're going to end up with x is equal to 5. So I know that the first part of my solution is 5. Then all I have to do is take this and substitute it back into either one of these equations and solve for y. Well, let's go ahead and just plug it into the top one. So on this, when I plug it in, for x, I'm going to plug in 5. So we're going to do 4 times 5 plus 6y is equal to 32. Go ahead and simplify as we can. That would be 20 plus 6y is equal to 32. We're trying to isolate y, so we need to undo the addition first. We need to subtract 20 from both sides. When I subtract 20 from both sides, I've got 6y is equal to 12. Then it's just a matter of dividing by 6 to finish isolating y. We get y is equal to 2. So our solution to this system of equations is the ordered pair 5, 2. We could plug those in and do a quick check, which would be 5 times 4 would be 20. 20 plus 6 times 2 is 12, so that would equal 32. And then down here we would have 3 times 5, which would be 15. Negative 6 times 2, which would be negative 12, resulting in 3. Okay? Any questions on that? That was an example of using addition to solve. Let's take a look at when we would have to subtract. All right. On this one, when I look, my like terms are not lined up. So the first thing I want to do is I want to set it up to where they are lined up. So I'm just going to rewrite the first one as 5r plus 2t is equal to 6. And I'm going to rewrite the second equation. Well, basically I'm just going to rewrite it. I don't have to change anything in it. So we're going to start out with 9r plus 2t is equal to 22. All right? We're going to set it up here. We're going to kind of divide it up so we can take a look at it. Now, our coefficients that are the same or opposites is positive 2 and positive 2. On the previous problem, we added the equations together because we had opposites. We have the same. So to get this to 0t, I'm going to need to subtract. And I'm going to subtract each one individually. So 5r minus 9r would be negative 4r. A positive 2t minus a 2t would be 0t. 6 minus 22 would be a negative 16. From there, this just is eliminated because 0 times t is 0. So now we have negative 4r is equal to negative 16. We've got to go ahead and isolate r by dividing by negative 4. So we have r is equal to a positive 4. Okay, alphabetical order here, we're going to put r first. So in our solution, we're going to have 4 is the first part of our solution in our ordered pair. Now we're going to take 4 and plug it into either one of these equations up top. So I'm going to replace r with 4. I'll just go ahead and do it in the first equation. So I've got 2t plus 5 times r, which is 4, is equal to 6. All right, we need to simplify. So 2t plus 20 is equal to 6. I need to divide both, subtract 20 from both sides. In doing so, I get 2t is equal to negative 14. Divide both sides by 2, and I get t is equal to negative 7. So we've got a negative 7 here. If we want to do a quick check here, we need to plug in, for here we plug in negative 7, and 2 times negative 7 would be negative 14, plus 5 times 4, which would be 20, and that would give us a result in a positive 6. On the second one, if we plugged in 4 for r, that's 36, plus 2 times t, which is negative 7, which would be plus a negative 14, which would result in a positive 22. So our solution for this one would be the ordered pair 4, 7. All right. One last thing here. Ooh, a word problem. Okay, so we've just got to figure out what our two equations in our systems are. So if we just read this and write it as we read through it, it says negative 3 times a number, so I'm just going to say negative 3x, plus 5 times another number, so plus 5 times y, is equal to negative 11. All right, let's read that again. Negative 3 times a number, negative 3x, plus 5 times another number, plus 5y, is equal to negative 11. Let's read through and write our second equation. It says 3 times the first number, so 3 times x, plus 7 times the second number, plus 7y, is equal to negative 1. All right, so we have our two systems. If looking at that, if we set it up and try to decide what we're going to do with it, do we have opposites or like coefficients? Well, we've got opposites. And to get rid of that, to eliminate that, we need to add those together. So when I'm gonna make this an addition problem. So negative 3x plus 3x is 0x. 5y plus 7y is 12y. And negative 11 plus negative 1 is negative 12. So our resulting equation there is going to be 12y is equal to negative 12. To solve that, we're going to divide both sides by 12. So we have y is equal to negative 1. So in our ordered pair, in our solution, we know that y is negative 1. We'll go back here and get one of our original equations. Let's just do the top one there. And it says negative 3x plus 5 times y, and we know that y was negative 1, is equal to negative 11. So negative 3x plus a negative 5 is equal to a negative 11. They're adding a negative 5, so we need to subtract a negative 5, which is adding a negative here is basically subtraction. So if we add a 5 to both sides, we're going to end up with negative 3x is equal to negative 6. Then we need to divide both sides by negative 3. Divide by negative 3, we get x is equal to a positive 2. So our solution would be the ordered pair 2, negative 1. We can plug it in real quick and just do a quick check on this. Negative 3 times 2 would be negative 6. 5 times negative 1 would be negative 5, plus a negative 5, which would be negative 11. Down below here, we have 3 times 2, which would be 6, plus 7 times negative 1, which would be plus negative 7, which results in a negative 1. Now it's up for you to decide. Well, today you're going to use elimination on your assignment, but after we practice elimination a few times, you're going to realize, you're going to see that some problems are easier to solve using substitution, and some are easier to solve using elimination. So, you know, after a couple days of practice, it's going to be up to you to decide which way you want to go. All right. Hope this video helps, and see you next time.